Hi everyone, thank you for joining us on this webinar on this talk on serverless in production. My name is Yan. I'm a principal engineer at a company called The Zone, where we are a subscription-based platform for watching sports, both live as well as on demand. Before joining The Zone, I worked for a startup called Yabble, which is a social network that you can think of as a mix of Instagram, Twitter, and Facebook. And when I joined Yabble back in 2016, around April time, we had a pretty standard monolithic setup where we have a couple of Node.js applications running on EC2 instances. And being an early age startup, we didn't have that much traffic, so our baseline traffic is pretty low. But we did manage to invite a few influencers from other platforms. And Emily, for example, was one of our biggest users, and she had over 40,000 followers even at a time when we only had about 600,000 or 700,000 users on the platform. And Emily and other social network influencers, they will run campaigns on our platform whereby Emily will create a post and say, hey guys, come and vote on this post and I will announce a lucky winner for this designer handbag at 10 o'clock tonight. So there you go, basically very low traffic all the way across until just about 10 o'clock when a whole flood of people comes in to check whether or not they were the lucky winner for Emily's designer handbag. And since our system was all running on EC2 and we had to accommodate for all these unpredictable spikes, so we tend to run our cluster at a very low utilization level. And since scaling is so slow, it takes us about 15 minutes to get a new instance ready and serving requests behind our load balancer. So we also tend to scale up a lot early as well. The average on AWS is about 70% before CPU before you try to scale up. For us, we were scaling up around 50%. So that means we're spending a lot of money on resources that we are just not using. And at the time, deployment took up to about 30 minutes as well and required downtime. So that's just clearly not good enough for this day and age. And when I joined, I sat down with the team and we came up with a list of criteria of things we want from architecture going forward, including wanting deployments to be small, to be fast, have no downtime, and we also don't want to be in a situation where we have to do lockstep deployment with the client teams as well. And we want features to be loosely coupled and independently deployable. And from the operational side of things, we want to be more efficient and cut out all the fat that we have in our AWS build. And we want to minimize the amount of time that we babysit our infrastructure. And we also want to get rid of all this technical mess that we inherited. But whilst we do that, we want to continue to deliver value to our customers. In fact, we want to do that at a faster speed than we've ever done before. And if you just forward a few months' time, we arrived at an architecture that's both event-driven as well as service-oriented, where Lambda is the centerpiece that glues everything together. At that point, we had about 170 functions running in production, and we were paying for Lambda at about 5% of what we pay for EC2. Most important for me, though, is we've gone from about 4 to 6 deployments to production a month because deployment was slow and because deployment required downtime as well, so we didn't want to do them often, to by the time November came around, we were easily doing 80 to 100 deployments per month with the same size team. So we didn't have to hire a whole army of developers to go faster. Instead, we just give them the right tools so they can be more productive. From deciding that Lambda is a good fit for the direction that we want to go to having that first function actually running in production, we had to answer a whole bunch of questions around how are we going to do CI/CD, what about testing, logging, monitoring, and so on. And as our system expanded to have more services and more functions, many of them have interdependencies, we also had to answer questions around how do we do distributed tracing, config management, and security, and so on. To give you a few examples of things that we were able to achieve very quickly, when I joined the company, we already had the search feature that is essentially one big regex query against MongoDB, which, as you can imagine, just didn't scale or perform very well, and we were running into performance issues at about 100,000 user mark, which is nothing compared to the heights that we want to reach. And it was really difficult to do anything beyond rudimentary ranking. So one of the first things we did was to make sure that the legacy system is now publishing all state changes as events into Kinesis so that we can have a Lambda function that will process user-specific events, user created, user profile updated, and so on, and use them to update user index in Amazon Cloud Search. And so we can build an API in front of that with API Gateway and Lambda to give you an easy way to search users by first name, last name, and username, and so on. And we could also support the fuzzy search as well as support ranking based on how prominent you are in a platform and whether or not your account is trending as well. And as we got more comfortable with running Lambda functions in production, we also started to tackle more important parts of the system. We had a timeline feature just like Twitter's timeline, except our implementation was really badly broken. Most of the QA test was failing, and the implementation was so complicated that even the team that built the system couldn't debug it to save their lives. And at this point, a new CTO has come in and fired the old team, so we also didn't have people to go back to and ask questions about why were certain decisions made. So we sat down with the product team to figure out what they actually wanted from the feature and went about building it from scratch using events the legacy system is now publishing whenever you follow or unfollow someone and whenever you create a new post or liking somebody else's post. And these events are handled by a bunch of Lambda functions. In the case of you publishing a new post, we figure out who your followers are and we group them into groups of 100 and publish a new message to SNS for every group, which then triggers another Lambda function who will then update your followers' feeds with your post. And your followers' feeds are stored as a sorted set in Redis. And the reason why we proxy through SNS is so that we get the retry and delta queue support out of the box, so that we can minimize the number of times we need to do the expensive part of the work, which is figuring out who your followers are. As you can imagine, for a social network, as we scale, we're going to have users with millions of followers, so that those kind of query can become really, really expensive. Once with the data in Redis, we can then also build an API in front of it so that we can return you a user's feed. And as part of our migration strategy, we will also update the legacy endpoint to route requests to these new APIs we are creating so that we don't have to wait for the client application to catch up and we can deliver new features to our customers right away. And that's just some examples of work that we're able to achieve very, very quickly. I want to talk about some of the things you need to be aware of before you should go to production with serverless. The first and most important lesson is that don't write your own deployment framework. Use one of the try and tested frameworks out there. The Serverless framework is the most popular one. It's got a fantastic plugin system and it's got a lot of support and momentum from the community as well. And besides that, there's also Amazon's own SAM framework, and then there's also other smaller frameworks around as well. And once you have your code written, you also need to figure out how to test it. And for testing, this is my favorite book, and it's the first book I found that actually talks about what we now call the pyramid of testing, where you've got a unit test that tests your code at the object level, and nothing's changed here. If you've got some business logic encapsulated into a small module, you can also write unit tests against them, and then you've got integration tests that test your code against code you can't change. And since Lambda is ultimately just a function that Amazon calls on your behalf, there's nothing stopping you from calling the same function locally using a stub event and context object. And once your code has been deployed, you also want to run tests to make sure that everything's working end to end. And as you go up and down this pyramid, unit test is going to give you a lot more faster feedback loop, but acceptance test is what's going to give you the confidence that what you develop will actually work. One of the key lessons I learned from this book is that you shouldn't try to mock types you can't change because, and I will quote, we find that tests that mock external libraries often need to be complex to get the code into the right state for the functionality we need to exercise. The mess in this test is telling us that the design is not right, but instead of fixing the problem by improving the code, we have to carry the actual complexity in both the code and the test. And the second risk is that we have to be sure that the behavior we stop or mock matches what the library will actually do. And even if we get it right once, we have to make sure that the results remain valid when we upgrade the libraries. I think the same principles and same risk apply when it comes to mocking services that we can't change in this increasingly service-oriented world that we live in. And fundamentally, I also think that serverless just requires a different way of thinking about testing than what we had before. If you focus all of your testing effort on what goes on inside your function and you're stubbing and mocking out all of your dependencies, then you're going to miss out on a lot of things that's going to go wrong the moment your functions is released into the wild. For me, If I work on a new feature and I deploy it the first time I run, there's a chance that it may fail because I've forgotten to give my function the right permission to talk to, say, DynamoDB. And then I fix that and deploy it again. The second thing that's going to fail is that the table is not actually created because I haven't included it as part of my deployment pipeline to create the tables. And these challenges around configuration and resources that you depend on just going to magnify when you have more and more and more functions as part of your system. And it's my observation that with Lambda, most of your code actually becomes super simple. The things that can go wrong tend to be how your function interacts with the outside world. And since the whole purpose of us writing code is so that we can ship some working software at the end, we really need to optimize towards shipping working software, even if it means that sometimes we have to slow down our feedback loop as developers and write more integration and acceptance tests as opposed to unit tests. Another thing that I learned from the book is that wherever possible, an acceptance test should exercise the system end-to-end without calling directly into its internal code. An end-to-end test interacts with the system only from the outside through its interfaces. So going back to the search API example I gave you earlier, to test this system, we will interact with the legacy system from the outside by talking to it using HTTP to create new users, and then we'll validate that within a reasonable amount of time. We can call the search API to look for users by first name, last name, and username, and so on. And when we run our integration test, we are calling our code locally and talking to the real downstream systems. And once our code is deployed, now we are also running end-to-end tests against the same code, but in this case through API gateway or through what are the event sources that we are using. The observation is that the only thing that's different between our integration and our acceptance test is in how our function is invoked. When we write our test cases, we can make sure that these test cases can be reused by creating our when definitions with a toggle that allows us to run the same steps by invoking the function locally, as well as by interacting with the function through HTTP against some deployed endpoint that we have created. And once you've got automated tests sorted out, you also need to think about how you're going to do deployment as well. And here is one of my peeve annoyances whereby you have deployment scripts that only lives on a CI box, and at some point someone's going to make a mistake and it's going to break the build pipeline, but you have no source control to tell you what was there before, who changed it, so that you can easily roll back to the previous version. And for that reason, we have a rule that in our team, every project needs to have a very simple build script that builds on top of what you get with NPM and the serverless framework, so we can use it to drive testing as well as the deployment process. And once the deployment is done, we will run the acceptance test as well. And it's a very simple build script. The only thing of interest here is that we are using a dev dependency version of the serverless framework that's been installed into the project for deployment as opposed to the version that's installed on the machine. This is so that whenever they introduce the breaking changes to the framework, we can mitigate all the version conflicts between what's installed on your machine versus what's used for that particular project. And since it's just a very simple build script, you can run it locally as well as on a CI box, which makes the debugging build pipeline problems a lot easier. And then as for continuous delivery versus continuous deployment, we were doing continuous delivery where deployment to production is a manual step. In this case, we are following Git flow, whereby as soon as something is merged into develop, we will run unit tests, integration tests, deploy to the dev environment, and then we will run the acceptance test as well. And for any release builds, we also then promote those builds up to the test environment, do the same thing, then to the staging environment, run the same test, deployment and acceptance test. And then after that is a manual process for someone to click a button to deploy to production. We also had a rule to not ever deploy on Fridays because we also have Friday afternoon drinks as well. And once our code is running in production, we need to figure out how we can monitor things. And anything that your function writes to standard out would get captured by the Lambda service and shipped to CloudWatch logs asynchronously without adding anything to your function's invocation time. And you also get UTC timestamp, request ID as well. But the problem with CloudWatch logs is that it makes searching really hard. You can't search across multiple functions at the same time. So what most people do is they will go to the console, pick a log group and say, I'm going to stream everything to a Lambda function. And from there, I'm going to ship everything to a self-hosted Elk stack or logs.io or Splunk or whatever I actually want to use. And the problem here is that you have subscribed a new log group yourself. So what you could do is to automate that process by creating a Lambda function with the CloudWatch event pattern against the create log group API call that you can capture using CloudTrail, so that whenever you create a new function, the system will create a new log group for you, and you capture the API call and you call this subscribe function to then subscribe the new log group to your log shipping function. And you also do the same thing for updating the retention policy as well. By default, CloudWatch logs will keep your logs forever, which also charges you, I think, 3 cents per gigabyte per month. And since you're shipping all of your logs somewhere else already, it really doesn't make any sense for you to be paying for logs in CloudWatch logs forever. And having all of your logs in one searchable log aggregation service is all great, but when you have a complex system, you're going to need more help as well. For example, in the case of you creating a new post, quite a number of functions need to work in perfect tandem to bring that post to your followers' feed so that when they come into the app, they will see it. And what happens if one of the users says that his followers didn't get his new post? When you try to debug this issue, you have to look at the logs for various different functions and try to correlate between them. And it's a very difficult task, and that's where correlations IDs come in. And since the initial data flows through Kinesis events, through SNS topics, through HTTP endpoint, it also means that your correlation IDs need to flow through those event sources as well. And the way we approached it was to create wrappers for our favorite HTTP client as well as the AWS DK client, so that we can forward those captured correlation IDs. In the case of HTTP, they will be captured and forwarded as HTTP headers. For SNS, they will be captured and forwarded as SNS messages attributes. And for Kinesis, there's no good place for you to put those correlation IDs, so we put them as a special field inside the JSON payload that we published as events. We also integrate with X-Ray, which gives you instrumentation to see what is happening inside your function, where time is being spent, and you can also get this service map view for your function as well. But as of right now, X-Ray doesn't support API Gateway, and it doesn't support async event sources like Kinesis and SNS as well. And in terms of monitoring, one of the big challenges here is that we can no longer install those monitoring agents on our EC2 servers. So we are more reliant on the metrics that we get from CloudWatch. A bunch of other vendors have now started to support Lambda, and most of them, they just get the metrics from CloudWatch and give you a better dashboard in front of it. What the guys at OurPipe is doing is slightly different. They give you a wrapper around your function so that they can intercept invocations. At the end of invocation, they will send some metrics to your own system. But the problem here is that now that with Lambda, everything you want to do has to be done as part of your function invocation time. And when you're talking about API Gateway, the API Gateway doesn't get a response from your function until it's completely finished executing, including sending any metrics to OurPipe, which means now you're doing more work and you're taking longer for API Gateways to respond to your caller, which means that in terms of response time, you're taking a hit there. And the best workaround I found is for you to write your metrics as a specially formatted log message in the CloudWatch logs by just writing them to standard out, which then gets captured by Lambda service and shipped to CloudWatch logs, so you can post-process them, filter them out as metrics and send them as metrics to your monitoring system instead of as logs. And once you have all of your metrics, don't forget to set up dashboard and alarms as well. And finally, let's look at config management, where you want to make sure that all your sensitive data are encrypted at rest as well as in flight, and that you have a role-based access to those sensitive data you have. Fortunately, with SSM parameter store, you get both out of the box. So here you have some admin person to put secrets into parameter store, maybe via some automated process that fetches them from GitHub, where you have them stored in the encrypted form. And SSM private store, you can also encrypt everything using KMS, which has got a role-based access, so that all those data are encrypted at rest inside parameter store as well. And when your function boots up, you will ask parameter store for those configuration values, which again happens over HTTPS. So you get encryption in flight and also control using KMS for the decryption part of as well. So that's a quick summary of all the things I've learned in the last couple of years about running Lambda in production. And everything I've learned, I've also been putting them into a video course I'm producing for Manning, which you can find with the link at the bottom of your screen. And you can also get a 40% discount whilst we're still in the early access program. Thank you very much for listening in.